Hey everybody, we're going to talk a little bit more about solving quadratic equations today. Okay, so with the quadratic formula, we can easily handle any quadratic equation, okay, even ones that have weird fractions in them and stuff like that. So we can take this one. Of course, I know that my A is 1, my B is -3, and my C is 5/2, okay? So x equals -b, that's +3, plus or minus the square root of b squared, that's going to be 9 minus 4 times 1 times 5/2, all over 2 times 1 is 2. Okay, so x is going to equal 3 plus or minus the square root. This is going to be 9 minus 10. This is going to be -1 over 2. Now we just got done doing complex numbers, so we know this is I. So x is going to equal 3 plus or minus I divided by 2, or sometimes more convenient to write it like this, 3/2 plus or minus I over 2. Either one of these is correct and acceptable. Okay? So piece of cake there. Let's have you do this one, and then when you're done, take a look at what I get. Okay, so my A is 3, my B is -5, and my C is 1. X equals -b, that's excuse me, going to be +5 plus or minus the square root. B squared is going to be 25 minus 4a c all over 2a. 2 times 3 is going to be 6. So x is going to equal 5 plus or minus the square root. That's 25 minus 12 is going to be 13 over 6. And I'm done. Okay, really no reason to write it any other way. This gives me my exact answer. So remember, it's 5 plus the square root of 13 over 6 and 5 minus the square root of 13 over 6. Okay, from 1970 through 1990, the sales A in millions of dollars of television and FM antennas in the United States followed this formula. A equals -0.2 t squared plus 3.5 t plus 70, where the t is the year, with t equals 0 being 1970. According to this model, in which year did the sales of antennas reach 95 million? So for all you youngsters who don't remember, everybody used to have one of these on their house so that you could pick up the TV stations. Okay, now pretty much everybody has cable or internet and streaming, and so you don't need that. So 1 is going to equal 95 million. So what we're going to do is we're going to take 95 and substitute it in here for A. Write out our equation. Okay, and now let's put it in standard form, so we'll move this over here. And we get this equation right here. So my A is going to be -0.2, my B is going to be 3.5, my C is going to be -25. Okay. So x equals -b plus or minus the square root of b squared. So 3.5 squared, it's going to be 12.25 minus 4 times -0.2 times -25 all over 2 times -0.2 is going to be -0.4. Okay, so then we've got some negatives that cancel out here, and I get x equals -3.5 plus or minus the square root. Okay, this is going to be 12.25 minus, let's see, 4 times 25 is going to be 100 times 0.2 So that's going to be 20. Hang on. Gone brain dead. 4 times 0.2 times 25. That's 20, yeah. So 12.25 minus 20 over negative 0.4. Okay, what does this tell me? This tells me this is going to be negative. My discriminant is going to be negative, which means I've got an imaginary solution, which means since the discriminant is negative, that implies there's no solution, no real solution to this equation, which means they're never going to hit $95 million, at least on that time period. So that's that. You're going to have a bunch of quadratics with some nasty numbers in them, and good luck with those. I'll talk to you guys later.